Computer Programming for Kids, Step 7. Crunching numbers and guessing ages. We will now calculate the final score, our guess of the user's age range, and add some visual indication to the user to display their final score to them. Each time the user makes a selection and then clicks the next button to move on to the next question, their points for the just answered question, the value of the underlying tag property of that selection, is added to their total. To recap, for each option most likely to be chosen by a young person, they get 1 point. For each option most likely to be selected by an older person, they get 3 points. The in-between choices are given 2 points. To do this, add the following code to the button click event. New code bolded. And then in the newsletter, you'll see quite a bit of new code added, which deals with the various radio buttons being checked, what code you had in those situations. Note, you might be a little confused by the code above, as it shows the tag value being converted to a string via a call to toString, and then that value being converted back into an integer via int32.parse. You might wonder, since we are storing an int value in the tag property, why can't we just add the age score variable and the tag value together without jumping through these hoops? The answer is that the tag property is not of the int data type. You can store an int in it, as we are indeed doing, but it is actually a generic data type, specifically an object, which can be anything. All you really need to know for now is that we do have to jump through these hoops to access the tag property's value as an int. In the code above, the value of the clicked radio button's tag property is added to the current value of the age score variable, which keeps incrementing at least by 1 each time a selection is made, and the user moves on by clicking the next button. In other words, if the user chooses radio button 1, the value of radio button 1's tag property is added to the age score variable. Each radio button could have a tag value of either 1, 2, or 3. If they just happen to be the same value as the number that is part of the radio button name, meaning if the tag value of radio button 1 is 1, it is just a coincidence. Based on the law of averages and logic, it will happen about 1 time out of 3, since we have 3 radio buttons and 3 different numbers being used. For example, if the user selects Federer in response to select a Roger, the value of the tag property that we will add to the running total for the user's score will be 1, because that is someone young people may be familiar with. If the user selects Ebert, on the other hand, the value of the tag property will be 2, because he is somebody that people who are neither especially old or especially young are probably familiar with. Finally, if somebody selects Maris, the tag property would have a value of 3, as the older generation would be the ones most likely to remember the 1960s New York Yankee slugger Roger Maris. And then a photo collage of those 3 Rogers are shown. Roger Federer on the left, playing tennis. Roger Ebert in the middle, talking on a radio show. And a picture of Roger Maris, the baseball player, on a baseball card, it looks like, on the right. After the last choice is made, the code will detect that the end has been reached and show the user's total points or score, and then visually indicate which age range the user, at least apparently, falls in. First, though, we have to add something to the form so that we have a place to display that information. Follow these steps. 1. Drag a progress bar control, highlighted below in the screenshot, from the toolbox to the bottom of the form and drop it there, below the group box, on the other side of the form opposite the next button. And of course, a screenshot is shown, with the toolbox open and the progress bar highlighted. 2. Enlarge the height of the form by clicking and pulling down on its resizing thingy, circled below. And there is a screenshot of that. Alternatively, you could change the height value of the form in Visual Studio's Properties pane, but it's usually easier and quicker to just manually resize it by dragging it. 3. Move the Next button up a little. Move the progress bar down to the bottom of the form and then resize it lengthwise or horizontally by dragging it out to the right so that its far or right edge aligns with the right edge of the button, more or less anyway. It doesn't have to be that precise. 4. Now drag 3 labels from the toolbox to the form and place them above the progress bar, but below the group box with its radio buttons. 5. Change the font size property value of the labels to 13 and set their bold property to true. 6. Change the text values of the labels so that they are, from left to right, whippersnapper, 9-0, NYNO, and geezer. Your form should now look something like this. And a screenshot is shown of the form with these controls and components added, the 3 labels and the progress bar. So at the end, we will set the value property of the progress bar to the number corresponding to the total points the user of the app has amassed. The value of the maximum property of the progress bar is already set to 100, which is what we want, and its minimum to 0, which is also what we want. But wait a minute. How is the math going to work for this? We have to work it out so that if the user has always selected the whippersnapper answer, the progress will be all the way against the left edge at 0, the minimum value. And we want it so that if they have always selected the geezer answer, the value property will be set to 100, the maximum value, so that the progress bar is colorized all the way over to its right edge. But since we are giving whippersnapper answers 1 point each, that will be a total of 10 points if all the answers correspond to what a young person would presumably select. And since we are giving geezer answers 3 points each, that will be a total of 30 points for a person who answered all questions expected of an old person. But a pure whippersnapper should actually end up with a total score of 0, not 10. And a solid geezer should end up with a total score of 100, so it doesn't seem like this is going to work. There's nothing we can multiply 30 by to make it come out to an exact 100. Multiplying 30 by 3.33 would come close, 99.99, but not quite get there. So what we're saying is this. For a pure whippersnapper to end up with 0 points, each whippersnapper point should be 0 instead of 1. So what if we change the points for each whippersnapperish answer to 0, change the points for each 9-0 answer to 1, and change the points for each geezer-esque answer to 2? That would certainly work for our whippersnappers, as 10 times 0 equals 0, which is the value that we want in order for the progress bar to represent a pure whippersnapper. But what about arriving at 100 for a complete set of solid geezer answers? Would 2 points for each geezer answer work? Yes, that is, if we multiply the total by 5, since 20, the new solid geezer score, is 100 when multiplied by 5. And for the in-between spot, 9-0, the total score would be 10, and 10 times 5 equals 50, which is right in the middle of the scale, right where we want it to be. So, we want to multiply the final scores by 5. Will that work? Well, 5 times 0 equals 0, representing the pure whippersnapper. Yes, in that case. And 5 times 10 equals 50, representing the dyed-in-the-wool 90, so yes in that case too. Finally, 5 times 20 equals 100, which is just what is needed for the perfectly geezerish person. Which means that we have to change our code. We have to, as programmers refer to it, refactor our code. This is realistic because you will often find that you need to change something in your code as a result of not thinking everything out thoroughly beforehand. It's okay. It happens. All the time, in fact, to one degree or another. That's why there's a word for it, refactoring. It's definitely a thing that programmers do pretty often. The good news is that we already created constants to represent the values assigned to whippersnapper, 90, and geezer answers. So instead of changing 30 bits of code, changing all the 1s to 0s, all 10 2s to 1s, and all 10 3s to 2s, all we have to do is make 3 changes where the constants are declared. Declared is programmers speak for written or introduced. So we change this where the constants are given values of 1, 2, and 3 to this, where the constants are now given values of 0, 1, and 2. And all the tag property assignments are updated in effect to reflect the new values. In the next step in our journey, we will add the code that causes the progress bar to show where on the age continuum or range the user of the app is apparently located.